turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
Hello and welcome to The Naked Scientists, the show that brings you the latest breakthroughs in science, technology and medicine. I'm James Titko. Coming up this week, why nearly 2,000 tech experts and scientists are calling for a halt to AI research. We talk to one of them. Why you need hands to be fooled by a magic trick. Birds, it turns out, can see straight through them. And simply inexcusable, the words of the World Health Organization as it condemns China's failure to share key COVID data from the beginning of the pandemic. Plus, the science of pain is on our examination table this week. How does pain work? And why is it usually a good thing? And why for some does it become incapacitating? We'll find out.
The Naked Scientists podcast is powered by ukfast.co.uk.
Recently, more than 1,800 technology leaders and researchers, including technology entrepreneur Elon Musk, penned an open letter urging artificial intelligence labs to pause development of their most advanced systems, cautioning that AI tools present, quote, profound risks to society and humanity. Now, Chris Smith wanted to know what those in the field believe those risks are, so he asked Harry Shevlin from Cambridge University's Centre for the Future of Intelligence why he signed the letter and what he most fears.
Realistically, I think it's going to be very hard to slow down AI research for 6 months, let alone stop it. But I signed it because I thought it was a good idea to draw greater public attention to the fact we are playing with fire here. I think AI is an amazing technology with real potential for good. People compare it to things like the invention of electricity or the internet or even the microchip. And I think those comparisons are apt, but at the same time, there's massive potential for misuse and harm. And I think we just need to get a good handle on what's happening and not rush blindly ahead.
When you say there's risk of misuse and harm, give us some examples of the kinds of things that this might unlock that we would rather it didn't.
So you get a whole panoply of risks. One that's already here that I tried out myself is voice cloning is easier than ever before thanks to AI. I can take a 2-minute clip of your voice, Chris, run it through an AI system. I won't say the website, but there are plenty of them out there, and then produce a voice that's basically indistinguishable from yours. So imagine if I then call up your producer and say, oh, hi, I've forgotten the code to the building. Could you let me in? For example, that's an easy way to conduct hacking attempts or even physical break-ins. And so there's a whole bunch of malware cases, of misuse cases associated with that. Then medium term, you can think about the use of things like autonomous weapons that we could potentially lose control over in war zones like Ukraine. And then the really long range stuff that I think a lot of people who signed the letter are worried about are the idea that we might lose control of the whole thing. Now, I think that's quite speculative, but I also think it's not a crazy thing to worry about. As soon as you start building systems that are maybe smarter than us, more powerful than us, you do have to make sure that we're still the ones in the driving seat.
People talk about 2050 as being the turning point where we might reach a threshold point where we have got things that are brighter than us. But based on what you're saying, we're almost there. 2050 seems a bit of an unambitious aim.
Yeah, well, if you look at these prediction markets where sort of experts can take different turns at sort of predicting how far these things are going to be away, how long until we get superhuman intelligence in AI. And if you look at sort of the predicted date for artificial general intelligence, it's sometimes called AGI, it's been shifting steadily backwards from 2050. And I think the average answer is now 2031. Now, of course, as the old saying goes, it's hard to make predictions, especially about the future. I think if you'd asked people 10 years ago whether we'd be able to create video and images perfectly from just typing a few words on a screen, I think people would have thought you were loony. And yet technology has moved really fast. But at the same time, you sometimes run into unexpected obstacles. You know, we might find that we start running out of data. That's something to train these models on. That's something people have been worried about. We might start to run into some difficulties in building bigger and bigger computers. But the one thing I would emphasize, that this is not an end of the world scenario. 2031 is the point where we think that hopefully we'll have systems that can do better science than us, can design cities better, can build better cars. I mean, there's a lot to be optimistic about there. We just got to make sure we've got our bases covered and, these systems don't run amok or do things we don't want them to.
Given the way we train these things by taking pretty much all the knowledge that we have at the moment on the internet and let the machine ingest it and basically see connections between all these different bits of data. But it's basically passively absorbing what we've already done, human endeavour. But what it's not able to do, therefore, is know what we don't know. And arguably that's what we want it to know. So is it actually able to think outside the box, or is it constrained by existing ideas and concepts that we fed it? And therefore it still leaves quite a lot of room for that je ne sais quoi about the human brain, the creativity that we bring to the party.
Yeah, I think it's a brilliant question and beautifully explained as well. It's tricky. I think one thing I would note is that sometimes even the information you already have contains things you haven't realized. So think about the way astronomy worked in the Enlightenment era, 17th century, discoveries of people like Copernicus. We had really accurate measurements of all the stars and planets, but it took a great mind to figure out how they all slotted together and work out that the sun was the center of the solar system rather than the Earth. So sometimes even in the data you already have, you can spot connections or new theories. Another classic example is think about Sherlock Holmes. Sometimes it's not the fact that he sees things that other people don't. It's that he can spot the connections between them. So even if this system is trained just on information we already have at our disposal, it's possible that, AIs will be able to spot connections or ways of tying together data that we haven't before. Now, creativity is a tricky issue. It's something I've written about in my own research, and I've got to admit I'm very enamored of the AI image models. I've had great fun playing around with them, generating cool artworks. I've got a couple of pieces on my wall. Are they creative? Well, I think they can certainly be beautiful. I think they can be interesting. Whether we decide to call them creative is almost a societal decision, I think.
With the call that's in your letter to hold fire on AI for a bit, what are you hoping that we should do in that 6 months or so that you're saying, look, let's just pause this for a minute? What do you think needs to happen?
I'll be honest, I always thought that the 6-month thing was unrealistic. I mean, it wouldn't be a bad thing if we did have the 6-month moratorium. But what I'm really hoping for is that this generates a broader public debate, because right now these systems are largely being designed and built by tech companies. And it's actually, even as an academic, I find it really hard to get policymakers to care about it. Some of your listeners may have seen shows like movies like Don't Look Up, where the scientists are desperately trying to get the politicians to pay attention to the problem. And it can be really hard to get policymakers' attention to say, look, we need a better public debate about this. We probably need more transparency. We need more regulation. So one of the things I was hoping for when I signed the letter is that this would just bump AI up the public and media agenda. And I think it's working, to be honest. And the amount of media coverage of AI, it's massively exploded since the letter came out. And I think a lot of the conversation is being carried out at quite a sophisticated, high level. And hopefully politicians are starting to pay attention.
Well, let me put you on the spot then. Where do you think the biggest breakthroughs in this area are going to come? Where is the average person going to see this impacting on their life, in your view, in the near future?
Well, I'm going to take a bold prediction here that I think is not necessarily one that all my colleagues would share, but I'm pretty confident in. I think we're going to see an increasing involvement of AI in our social lives in the form of AI friends, maybe even AI girlfriends or boyfriends. And I wouldn't be surprised at all if a couple of years from now, if you look at the top 50 influencers on TikTok or on Instagram, that there'll be some AI personalities among them, because we can already build AI systems that are fun to talk to, can be very charismatic. And now we're integrating text with video and images. I think we've got all the ingredients for a new age of AI celebrity culture, which is both exciting and a little bit worrying.
What a harrowing thought. I don't really like the suggestion that if Chris gave me a ring, I wouldn't be able to tell the difference between him and an AI version of Chris, but maybe that's naive of me. A very thought-provoking and interesting conversation there between Harry Shevlin and Chris, and I think you'll enjoy this next item too. Magic. It's not a term you'll find in many science papers, but strange as it sounds, scientists at the University of Cambridge have been using magic in their experiments for some time now. That's because classic sleight-of-hand tricks and illusions, the staples of any conjurer, are a good way to find blind spots and roadblocks in the thinking processes of different species of animals. In experiments with birds, Nikki Clayton realised that while the jays she works with were taken in by some tricks, they were not fooled when a magician used their fingers and thumbs to try and conceal the location of a hidden treat. Intrigued by this, she and her team decided to show the same tricks to primates, which do have fingers and thumbs, to see if they would fall for the same illusion, and so they did. In order to be fooled, they think an animal needs to have the same anatomy as the magician, as she explained to me.
If you distill magic down to the basics, it's about having an ability to see, remember what you think you saw, and have an expectation in the future. And that's the tools that allow the magician to violate your prediction of what you think has happened.
What sort of trick is a good vessel for what you're trying to study here? How do you subvert the animal's expectations like you would a human's? What tricks are in your arsenal?
Well, you can either use cuts, like the famous cup and ball trick, or the magician can use his or her hands, choreography of the hands, if you like, to make you think that the object is in one place when in fact it's in a completely different hand. So one of the most famous sleight of hand tricks is called the French drop. And that's one in which an object appears to vanish when a spectator assumes it's been taken from one hand by the hidden thumb of the other hand.
How was it that birds react to being shown this trick? Are they, what I suppose you're trying to ascertain is whether they're able to be tricked in a counterintuitive sort of way.
You're absolutely right, James. So we did a number of sleight of hand effects, one of which was the French drop. And we found that the jays were fooled by some sleight of hand trick, but they weren't fooled by the French drop. And that's interesting because one of the fundamental things about the way in which the French drop works is that you use your fingers and thumbs. So a key component of the illusion is that instead of performing a normal grabbing motion of the object, the thumb allows the object to fall to the opposite hand while simultaneously pretending that an object has been pinched between the thumb, the index finger, and the middle finger. The French drop depends on having an understanding of fingers and thumbs. So when a hand works like a wing, the jays are completely fooled, just like people are. But with a French drop, they're just not fooled. They don't have an expectation of what thumbs and fingers do. And that's actually what led us to look at monkeys.
I can see where this is going, yeah. Move this to an animal where they do have thumbs, and perfectly, you've got the control already there in the other species which don't have opposable thumbs.
That's correct. That's exactly what we did. Essentially playing with the animals, aren't we? And the monkeys and the zoo trainers absolutely loved watching Elias Garcia Pellegrin, the first author on the study, perform these effects.
And what were the findings?
Well, the cool thing was that the marmosets that don't have opposable thumbs behaved like the jays. So they weren't taken in by the effect. But the monkeys that did have opposable thumbs, so the capuchins that have proper opposable thumbs and the squirrel monkeys that have semi-opposable thumbs, were completely fooled by the effect, just as humans are.
It's so interesting, this idea that you need the physical anatomy yourself to be fooled by this trick. You must have been, or the whole team must have been, very encouraged by these results.
Completely different bits of your body shape other bits of your body. Who would have thought that your hands would have control of what you think you saw and remembered? Surely that's the job of the eyes and the brain. And yet it's all interrelated, right? You know, there's the lovely Jacob Bronowski quote, "The hand is the maker of the mind." And this, I think, is a lovely example of just that.
Well, I'm sure he didn't have an idea how right he was.
Exactly. He'd be very happy right now, wouldn't he?
The brilliant Nikki Clayton, and that paper was out this week in Current Biology.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientists with me, James Titko. Still to come, pain. why we have it, and how it can go wrong. But first, Maria van Kerkhove leads the World Health Organization's work on emerging diseases. This week, prompted by the recent disclosure of previously unreleased information from Wuhan regarding the origin of COVID-19, she's written a stinging editorial in the journal Science, in which she says, 3 weeks ago, the World Health Organization learned that scientists in China possess data on viral samples from Wuhan that had been gathered in January 2020, which should have been shared immediately, not 3 years later. The lack of data disclosure is simply inexcusable. Now, that's some very strong language. So what data does she mean, and what should our response be?
So there's data that was collected in the Wuhan seafood market. The data that became available contained molecular evidence. There were animals, in fact, sold at that market. Now, that was suspected, but it wasn't confirmed. But also that some of those animals that were sold at the market were susceptible to SARS-CoV-2 infection. And what that means is that there were potential intermediate hosts. And for scientists like myself and public health professionals around the world, this is a really critical finding because these viruses sometimes pass through another animal that could be at a market. We call those intermediate hosts before they infect humans. And so the data provided more clues to suggest that there were intermediate hosts at that market. And that was new information.
How did the data come to light, and where had it been in the meantime?
Well, the data was generated by China CDC, and the data was submitted to GISAID, which is a platform that hosts information and data on sequences and what we call metadata. It's supplemental data that talks about the sample collection date, where those samples came from, just more information. That was submitted to GISAID as part of research that was done by a group in China, which published a preprint last summer looking at these samples. And so the data existed, and the data collection, the sample collection date from those samples was January 2020. And so the challenge that we have as a global community is that this information has existed for more than 3 years. And we need this information to be shared so that it can be analyzed. And that's the big story here. That's the real crux of it. And maybe you haven't heard me speak because I feel like I've been so blunt about this for so long because this is not a game. This is about understanding how this pandemic, which has killed at least 7 million people, has disrupted every single one of our lives, has changed futures. We have to understand how this began. And data like this are critically important to be shared because by knowing this information, we take steps to mitigate, to prevent this from happening again. Because unfortunately, this will happen again.
The World Health Organization have performed one, so far, analysis back in 2020, 2021 of what is thought to have occurred to start the pandemic. Samples were requested then by the WHO, and China resisted providing them and still have resisted providing them. Does this fall under that same mentality? There's something here where getting information from the source is proving very challenging. And if so, why?
Yeah, I mean, you're referring to a mission that took place in January, February 2021 of international scientists and Chinese scientists to understand the origins. There was a mission specifically looking at the origins of SARS-CoV-2. And they published a report in March 2021 outlining what they were able to determine. And within that report, there were a number of studies that were recommended that needed to be conducted. And it included samples at the market, tracing the animals back, doing serology, which looks for evidence of past infection through antibodies of people who worked at the market within the animals themselves. And look, the start of any outbreak is incredibly challenging. And what you're majorly focused on right at the beginning is 5 questions. What is it? How is it spreading? What is the extent of infection? How far has it spread already? What disease does it cause? And what do we do? And at the time the cat was out of the bag, so to speak, the virus was already spreading. And so a lot of the efforts early on were on putting out that fire, stopping human-to-human transmission, reducing the morbidity and mortality, because we were seeing huge increases in deaths and hospitals were being overwhelmed. But in addition to that, there's always work that's done at that initial source, or what you think is the initial source. We knew the market played a really important amplification role because most of the cases were associated with that market. So the market was closed, the market was disinfected. That was the right thing to do. But what also happens at that time is samples would be collected. Those samples were collected. We knew that was happening. That's where some of the early sequences were identified, as well as some of the early sequences from the patients. And the question is, what happened to that information? Were there studies that actually traced the animals that we now know were sold there? Were these wildlife? Were these domestic species? Was this legal trade or illegal trade? And that's not a blame question. It's just getting to these answers, because we can't come away with this pandemic and say, we need better surveillance. We need better reporting. We need to actually know the exact drivers of this. Where did they come from in terms of the trade routes? What were the animal species that were there? The conditions by which they were raised, the conditions by which they were sold, so that we could do better, that we could prevent this from happening again. So a lot of those early days, that early work, I believe more was done. There's incredible scientific knowledge in China that this work maybe was done. And that's what we're questioning. We keep questioning, has this work been done? And if so, that data needs to be shared immediately.
The World Health Organization, though, came under criticism for almost singing from China's song sheet at the beginning. And people said you allowed a sort of puppet show to play out when that investigation went through, because people were whisked in a stage-managed way from one venue to another, and these sorts of samples and these sorts of data that were being requested, like, well, can we see some sewage samples or some blood samples from across China to try to gauge the spread? Those sorts of samples have still not been provided. One does wonder what else is there that could be shared and should be, and why are China so resistant to giving even organisations like the WHO access to this to help prevent the next pandemic?
Yeah, I think there's a bit of rewriting of history here, because what we were saying publicly, what we were saying to China, what we were saying to all of our member states, what we were saying behind closed doors, there was excessive requests for information on the cases that were known, on the extent of infection, on the case definitions, on the testing that was being done, on the samples that were collected from humans, from animals, from wherever it could be. And these were requested repeatedly. As WHO, a lot of people think we can just parachute into any country we want, walk in the front door and say, give us the samples. We don't have the power to go into countries and collect those samples ourselves and walk out with that, that suitcase with those biohazard stickers on it that people see in the movies. That doesn't happen. And listen, I'm just as frustrated as all of you on why we don't have this access. We work all channels, scientific channels, technical channels, diplomatic channels. Again, this is not a game. We're not playing around here and saying, what, it would be nice to have access to this information. We need access to this information so that we could do better the next time.
One of the things that people do find very frustrating internationally is that China has form in this area, because it was even with another coronavirus that they did a similar sort of thing 20 years ago when the first SARS emerged.
Yep.
There's evidence that was circulating, and we believe China knew it was circulating for maybe 6 months before they told the rest of the world. It then escaped the bounds of China, and there were thousands of cases. There were nearly 1,000 deaths because of that.
Yeah.
And people criticised China and said, you need to be more transparent. Here we are 20 years later, and history is repeating itself. Now we return to the question that we really first began to address here, which is why is there this reticence to be more open? Why not share this data unless, as some claim, there's something to hide?
It's beyond a health question. And I think it relates to the other questions that you were asking. What are the incentives to share? And more importantly, what are the disincentives to share? Now, we're focusing right now on China, but we do have challenges with reporting information from many countries. We have outbreaks that are occurring of other pathogens over the last over the last year in particular. We have challenges of getting information from countries. This is a problem and a challenge that we must face, and we must work on the incentives and the disincentives. I can talk to you about why it is important for this information to be shared, why the world needs to be vigilant, why we need to act faster, why it is so much better to prevent something from happening than to try to control it and end it once it has started spreading. And I can talk to you about the financial implications, and that it's much better to spend $1 million or $1 billion on pandemic preparedness rather than the trillions of dollars that we are spending right now on the response and on the economic impact of COVID-19. I can talk to you about governance. I could talk to you about responsibility and accountability. What I can't do is force countries to adhere to this. I do think this is why something like a pandemic accord is so important. It's a promise that we will do better, that governments will do better, that everybody has a responsibility and a collective responsibility to do better. Because forget these borders that we have within our countries. These viruses, these pathogens don't respect borders. We live in a completely interconnected world where a virus that passes from an animal to a human, or passes, let's say it was a breach in biosafety or biosecurity, into humans, once it's efficiently transmitting within humans, it can go from one part of the world to the completely opposite part of the world in 24 to 48 hours. That's why everything that we've done for COVID-19 in terms of surveillance, sequencing, improved diagnostics, sharing of information, better data management systems, better analytics has to be maintained. Because if we dismantle these systems and say, oh, we'll just scale them up for the next time, we're living in a fantasy world. This will happen again, but we have not addressed and we have not moved forward on this issue of transparency and sharing. And frankly, I'm very concerned that we're almost in a worse situation than we were before this pandemic began. And that is because of the politicization. That is because no one wants to find that next pandemic virus. No one wants to be blamed for this. But collectively, as a species, we all need to be working together on this.
Some very passionate points made there by the World Health Organization's Maria Van Kerkhove. And I expect that's not the last we'll have heard from that story. And of course, we'll keep you across all of the updates right here on The Naked Scientists as and when they happen. And now, you might have heard of the paleo diet, but how about food literally from the Paleolithic era? A cultivated meat company from Australia has created meatballs made of mammoth. Yep, you heard that right. So what was involved, and what on earth was the point? Will Tingle has more.
We have been producing alternatives to farm-produced meat, be it soy or pea protein, as far back as 1877. In fact, that was John Kellogg of cereal fame. But this latest farm-free meat alternative goes back further than 150 years. Indeed, it goes back over 10,000 years. The Australian cultivated meat company Vow have just unveiled a mammoth meatball. And they aren't talking about the size. It really does contain meat from a woolly mammoth. Well, sort of. The meat in question isn't actually a hunk taken from a preserved body, but instead lab-grown with the help of some modern-day animals. So how did they manage to pull this off? Well, believe it or not, despite the mammoth going extinct 10,000 years ago, scientists have sequenced the DNA of the animals from mummified samples preserved in Siberian permafrost. This means we have the genetic recipe for every part of the mammoth body, and Ernst Wolvertang at the Australian Institute for Bioengineering at the University of Queensland used this mammoth sequence and a bit of modern-day elephant to fill in one or two missing gaps in the genome to grow mammoth muscle cells. Muscle, of course, is the key part of the meat we eat. The sequence of genes that make up mammoth muscle are only the instructions. They cannot make muscle on their own. So this gene sequence was added to sheep muscle stem cells that made mammoth muscle protein to create the Vow meatball. The big question is, of course, what might mammoth taste like? Well, currently, nobody knows. In Professor Wolvertang's own words, we haven't seen this protein for thousands of years, so we have no idea how our immune system would react when we eat it. Nevertheless, our close caveman ancestors were happily dining on mammoths until relatively recently, so it seems unlikely our own digestive tracts would have a particular problem with this menu option. Indeed, there was also the case of the Blue Babe, a 36,000-year-old bison preserved in the Alaskan permafrost, consumed by two of the people involved in its discovery, who goaded each other into stewing a sample of the bison with vegetables. They described it as bland, but anything is edible with enough onions. It's a bit of a stretch from this lone case to sanctioning chowing down on a mammoth, but implies that anyone who is wishing to sate their prehistoric palate might be safe in doing so. Maybe that's the paleo diet I've been hearing so much about. After all, domestic cows have been around and relatively unchanged for about 10,000 years too. But why resort to in vitro meat at all when we have ready access to the real thing? Well, in the fight to save the planet against the worst effects of climate change, invariably the emissions discussion turns towards the food industry. The process of using farming machinery, spraying fertilizers, and transporting the food, as well as the methane that cows and rice produce, accounts for around 26% of worldwide emissions. Farming large animals like cows or pigs generates significant amounts of greenhouse gases, with one estimate stating that 1 kilo of beef accounts for 70 kilos of greenhouse gas emissions. So looking at our diets and reducing meat consumption even by a small amount can make a big difference to our individual carbon footprints. So what drove Vow to such a stunt? Well, the CEO, George Peppu, was quoted as saying, "We have a behaviour change problem when it comes to meat consumption. The goal is to transition a few billion meat eaters away from eating conventional animal protein to eating things that can be produced in electrified systems." So, would you put down your beef burger for a mammoth meatball? The idea of cultivated meat, lab-grown meat without the need for a farm, is starting to gain traction too. The main obstacle between now and widespread production is governing bodies. The European Food Safety Authority, or EFSA, regulates this industry, and there are strict criteria for a new product to be approved for sale in Europe. However, 2 companies that make cultivated chicken meat have just passed approval to be sold in the US. So could there be a wave of cultivated meat appearing on our shop shelves, spurred on by the appearance of this mammoth meatball? Only time will tell. And, by the way, the irony is not lost on Vow that they chose an animal that died out due to climate change and human hunting.
Will Tingle. You're listening to The Naked Scientists with me, James Titko. Benjamin Franklin famously said that there are 2 certainties in life, death and taxes. But for the majority of people, we can add one other certainty to the list, pain. Almost all of us will experience this sensation regularly during our lives, and it's probably one of the most important sensations presented to us. That's because it teaches us an uncomfortable, but also unforgettable lesson, and provides an early warning about what we definitely shouldn't do. But for some people, it ceases to be a constructive lesson and becomes an incapacitating burden that destroys their quality of life. Thankfully, scientists are learning more about why some people spend much of their time in pain, and there are new developments on the horizon that may help us to combat it. And that's what we're going to look at this week. What is pain? How does it work? Why does it become pathological in some? And what can we do about it? But first, how widespread is the problem of persistent pain? Speaking with Chris Smith, Alan Fayaz is a consultant in anaesthesia and pain medicine at University College London Hospital.
Well, there is actually a very specific definition for pain. It's been marked out by the International Association for the Study of Pain, and they say that pain is fundamentally an unpleasant sensory and emotional experience, but an experience that is associated with actual or potential tissue damage. So that's the other factor. So when you break that down, it can't be pleasant. It has to be unpleasant. It's a sensory experience, but there is an emotional component to it. And that's what differentiates pain from other unpleasant sensations. For example, smelling a bad smell or eating bad food or listening to bad music. Those are unpleasant, but because of the strong emotional component to it, that's what differentiates pain. Finally, it is usually in the context of some perceived threat, but that threat doesn't have to be necessarily visible. So I don't have to see a broken bone to believe that you have pain. It's just that it's in the context of that tissue damage that it happens.
And if we pick an average person off the street, what fraction of people at any moment in time will say they've got pain?
There is a difference between acute pain, which is pain that essentially makes sense, pain for which there is an evolutionary basis. This is a signal from the outside world to your brain warning you that you've injured yourself. And then there's chronic pain, which is pain that's been present for a period of greater than 3 months. And that's no longer functional because the function of pain is to warn you, allow you to rest, distract you from the other day-to-day activities so that your body can heal and recover. But at 3 months, we would assume that all the healing and recovery that a body can do has happened. So at this point, we consider the pain to be dysfunctional, and that's often the point at which we would call it chronic pain. And in the UK, our study from 2016 suggested that somewhere in the region of between a third and half of the adult population experience chronic pain at any one period of time.
And who does it happen to? If we look at that proportion and we ask, are there any common factors or recurring factors? Do you see any trends?
There are some trends. Certainly with age, there are trends. So a tendency to be more common the older you get. So when we look at populations over the age of 75, approximately 2 in 3 older adults will experience pain. And a little less common if you're younger, but in some studies, some population studies in the UK, as many as 1 in 3 people under 45 years of age, so that, what we would consider the working population at the very least, experience chronic pain as well. But certainly a trend towards increasing likelihood of chronic pain the older you get, and perhaps a little bit more common in females than it is in males, and certainly more common if there are coexisting conditions such as depression, anxiety, and social circumstances have an impact as well. So if you are poorer, if you've had less opportunities for education, if you're unemployed, you're more likely to experience chronic pain than if you were not.
I've seen patients who say that they are very, very susceptible to pain. Is there any evidence that pain can run in families, or some people are genetically more susceptible to experiencing pain in a more pronounced way acutely?
Almost certainly there is a biological component that drives pain. We know, for example, that in general, females, contrary to common perception, have a lower biological pain threshold than males do. But again, even when we look at that, there are psychobehavioral, societal factors that may be causing that may be driving that. It might not just be genetics. It might not just be the sex of the patient. Going back to the definition of pain, it's a sensory and emotional experience. So we know the brain is involved in all forms of pain. I'm not just talking about complex, problematic, dysfunctional, chronic pain. I'm even talking about pain in the context of injury. What we think, what we believe, what we understand has a huge impact on what we feel and the way we feel it, with very different experiences. And that's why there is a strong emotional component to pain that I think genetics, it's not enough to explain the variations across the population and within an individual.
And presumably that emotional top-down control and role that's being played in pain must underpin some aspects of what we dub the placebo or even the nocebo effect, where you expect something to happen and so it does.
Absolutely. So there is kind of therapeutic value to it. There is also potential therapeutic harm, but it extends beyond that. It is really why we focus not just on a biological approach to managing pain, but understanding the importance of sociological, psychological approaches to modulating pain, and really the importance of being sensitive to the environment and the context and the person's beliefs and fears and anxieties and how they can impact on pain. Think about body aches from going to the gym. You go to the gym, you work out, the next day your body aches, but invariably you feel good about it. It's a nice feeling. You almost pat yourself on the back and you celebrate it and you go out. But if you have flu or if you have a cold, it's almost exactly the same sensation. It's almost exactly the same feeling you have in your muscles. But certainly if you're me, you're sort of very catastrophic about it. You feel very miserable, you feel down, you take to your bed. 2 very different responses to essentially the same stimulus. And again, this is reinforcing the idea of what does our belief about what's causing this, whether it's true or not, how does that drive what we feel? And how can we harness this therapeutically?
Alan Fayaz there. It's interesting, isn't it? For so many years, scientists thought that pain was a direct response to damage. The more severe an injury, the more it was going to hurt. But it turns out that pain and tissue damage don't quite go hand in hand, and we're capable of experiencing pain out of proportion to the actual injury. There'll be more from Alan later when we pick his brain for the best strategies to manage chronic pain problems. But first, he talked about 2 types of pain, didn't he? Acute or short-term, and chronic or long-term pain. In a moment, we'll hear why we think some people develop long-term pain syndromes. But first, we need to understand why things hurt at all. Stephanie Koch is a lecturer in neuroscience at UCL, where she studies how we react to pain and touch. She told me why feeling pain is not necessarily a bad thing.
It's something that really grabbed my attention when I first started studying pain, is we all think of it as such a bad thing, but it is the cue that our body is giving us to say, stay away from that. That's not good for you. That's going to harm you or potentially harm you. And a really clear example of this is a group of patients who are studied actually by another group at UCL, and they don't feel pain. They have a genetic mutation within their pain fibers within the skin, and this means they don't respond to pain. And this group of patients rarely live beyond the ages of 20, 30, because they'll burn themselves and not treat the burn because they don't realize they have it. It becomes infected. They'll break a limb and not realize and get septicemia. All these little events, if you think about any time that you felt pain throughout the day, you then take more care to take care of your body, to make sure what's happening around you. And these patients don't have that. And as a result, they suffer hugely, actually.
Pain is good, right? It's an evolutionary advantage. It's something our body needs to do to stop us causing ourselves more injury. And acute pain in particular is what I want to chat about for now. When does a non-painful stimulus become something painful? Is there a kind of trigger where, me just touching my wrist doesn't do anything, but if I was to prick it with a pin, I would feel pain?
Within the skin itself, you have different type of nerve fibers. There's nerve fibers that respond to heat. So those are the ones that are also sensitive to chili peppers, which is why chili pepper feels like a burn. And then we have ones for itch, we have ones for touch. So the first point is you'll have a nerve, and whatever the stimulus is, be it pressure, be it pain, you'll kind of activate the nerve with a pinprick, for example. The nerve suddenly becomes excitable, and this nerve will start firing the method by which the central nervous system can communicate with small electrical impulses. So you'll start to get action potentials that begin to fire. These then reach the central nervous system through the spinal cord. They'll activate, which leads to eventually not only a reflex recruitment, it goes directly to the motor neuron, so you move your hand away from the pinprick. So that's one pathway. And the other is it goes up to the brain.
Yeah, it's fascinating. The actual mechanism by which the nerve fibers sensitive to damage sort of get turned on in a way, how these connect to the central nervous system and the messages going back and forth there.
So you have skin, spinal cord, brain. That tells you this pain is in your left finger, exactly at the tip. So you know what to move. Within the spinal cord itself, it's just telling you that's bad, move away.
Interesting.
You have many layers of discrimination, of understanding what the stimulus is, because essentially our whole body, the outside of our body, you have a lot of surface area of the skin, right? Within the spinal cord as well as within the brain, the biology sort of evolves so that we have a 3D representation of our whole surface of the body kind of smushed together into a much smaller plane.
Like a map almost.
Yeah, exactly. There's many different ways in which we have so that your body knows how to respond to the information that's coming in.
And what is the natural response when the messages do get to the brain? What does it do about it?
This is why we have this, what I called convergence. So why we have all the information that starts off separate first, touch, pain, itch in the skin, it suddenly gets brought together within the spinal cord because the response in the brain depends on what you're doing. So everything has to come together. You'll have a quick response, which is what we were talking about before, when it synapses onto the motor neurons and you'll move away your hand, you move away your foot. But when it comes to what happens within the brain, it really depends on what you're doing. So the classic thing to think of is sort of battlefield analgesia. You know, if someone's on a battlefield, they're shot. Whilst they're running, they won't realize that they've been shot. Why? Because there's an area within the brain, within the brainstem, that kind of stops all pain from coming through whilst you have a more pressing need to survive. So stress, a fight or flight response, essentially. In contrast, if you're exhausted, if you're really tired, you've not had coffee in the morning, you stub your toe, it's suddenly the most painful thing you've ever experienced in your life. Because the body's like, okay, you need to stop. You need to stop. You need to calm down. You need to lie down. You need to take care of your toe. So the contrast of how you respond to something when you're stressed, when you're running, when you're rushed, versus when you're even very poorly, when you have a really bad cold, how things feel. The body isn't just like, this is pain, this is bad. It also says, this is pain, but what else is happening in your life right now? How are you going to respond to that to make sure that you're getting the best out of this? And we're able to protect what's needed to be able to survive. It's all about survival.
It'll never stop being amazing to me just how much the body's able to adapt to your circumstances on its own. And we can all, I'm sure, appreciate the feeling of stubbing your toe and not getting your morning coffee. They're all definitely very painful experiences. That was Stephanie Koch. You're listening to The Naked Scientists with me, James Titko. And this week, we're looking at the problem of pain. In a moment, how doctors try to manage it. But first, and chances are, almost half of you listening to this programme right now are feeling pain you've been enduring for 3 months or more. And that means you're experiencing chronic pain. As Alan told us earlier, this seems to be associated with some kind of change in the way parts of the nervous system's pain network behave. And our next guest, King's College London neuropharmacologist Peter McNaughton, thinks he knows why. He's discovered that chronic pain signals are triggered by a special ion channel, or pore, on the affected nerve cells. This turns on in chronic pain states and activates the affected nerve, producing incessant pain signals. The good news is that if he blocks it, at least in experimental animals, the pain is blocked too. He told Chris how it works.
Yes, acute pain, we made some large advances in that in the last 20 years or so. You activate these ion channels as they are in the membranes of the nerve cells, which fires off action potentials which go up to consciousness and say, ouch. Your description of inflammatory pain was pretty good as well. There are a whole slew of different chemicals that are released by inflammation that generate inflammatory pain. And mostly they're not acting on the same ion channels as I spoke a moment ago. The work in my own lab has shown that a different ion channel called HCN2 generates an inward current, causes firing of action potentials which say pain, pain, pain. Now, the view about 20 years or so ago was that in chronic pain, something different happens. Because what often happens is that the inflammatory phase subsides and it looks as though it's healed, yet the patient is still in pain. So the rationale was that there had been plastic changes in the spinal cord, so that the pain, in a sense, had moved inwards and become a pain memory in the spinal cord. I'm not saying that point of view is wrong, but there's increasing evidence nowadays that pain nerve fibers continue to fire even in chronic pain states. So something is causing them to continue to fire, even though apparently the site of the injury has healed up.
I guess the question then is, we all experience pain every day, whether it's tripping over a stone or standing on something or touching the hot cooker, but we don't all develop chronic pain off the back of it. So why is it that some people do get into these pain states, and quite commonly in the population, but it's not as common as our everyday experience of acute pain, and thank goodness it's not?
Well, there's typically a pathology of some sort that's driving it. Another example would be rheumatoid arthritis. patients that suffer from these types of arthritis suffer continuous pain in their joints. So I think there's pretty obvious pathology, which is damage to the joints. Work in my own group has shown that, once again, it's these HCN2 ion channels which are driving the pain.
Is sort of a summary then of that something, we don't know exactly what, but something triggers that particular channel or pore in these pain nerve cells to either become more active or you get more of them. And so the nerve cell becomes more active than it should be. It should have a sort of baseline level of activity, and the presence and activity of that pore means it's more active than it ought to be.
Yes, exactly. Although the baseline activity should be zero, because as I'm sitting here, I feel no pain whatsoever. So presumably none of my ion channels are active, and there are no action potentials, nerve signals that are going up to my consciousness.
Are those ion channels just sitting there doing nothing normally then, and something's turning them on, or has something changed in the nerve cell that it now produces those ion channels, those pores, and puts them in the nerve ready to make these aberrant signals?
As far as we know, it's the first of the two. The ion channels are there all the time. They are silent. They are there to detect pain. Normally, you don't have pain, but if pain occurs, they produce the inward current and produce the activity in the pain-sensitive nerves.
So what's turning them on then?
Well, what's turning them on? Inflammatory mediators. There's one that's very well known to pharmacologists called prostaglandin E2, a chemical that drugs like aspirin and ibuprofen act to reduce. The other class of analgesics, the opiates, act more centrally on the transmission of the pain signal at the first synapse in the spinal cord. And they are wonderful, wonderful painkillers, but they come with a side effect burden, which, I'm sure everybody's aware of. Addiction, death as a result from overdose.
But if one talks to patients themselves, they'll say that nothing touches this, doc. I take all these pills and I've still got the pain. Now, is that just because they've taken so many tablets that their pain has outstripped the ability of the tablets to control it? Or is the mechanism different, that we're now sort of shutting the pain stable door after the pain horse has bolted?
Well, the work from my lab really shows that it's this HCN2 ion channel which is critical in triggering long-term pain. And the channel can be driven by inflammatory mediators or possibly changes in the internal ambience of the nerve fiber, which switches on these channels as well. But it seems that these channels are extremely important in generating chronic pain. And one of the things that my lab's been trying to do is to develop blockers for this HCN2 ion channel, which in animals at least, these blockers deliver wonderful analgesia. So we're hoping to develop blockers which could go into use as more effective painkillers with fewer side effects. That's the hope, at least.
And we're all hoping with him. That was Peter McNaughton. So what else can be done? As we've been hearing, pain is experienced by many different people in many different ways. This is what makes treatment options a case of tailoring what might work best for you and what you're experiencing. But even then, there are many people for whom what we have is just not enough. Alan Fires.
For acute pain, you've injured yourself, or we've injured you. You've had an operation, you've had surgery, or something like that. Pharmacological measures are actually quite effective. So, you've got simple painkillers, things like paracetamol and anti-inflammatory. So these are things that you can quite often buy yourself over the counter. And they're really, especially when used in combination, quite effective at reducing inflammation, which is the main driver of acute pain. And then you've got, when the pain is stronger, then you've got stronger things like opioids, which, if I must emphasize, for acute pain are very, very effective. When that pain becomes what we call dysfunctional chronic pain, those painkillers are far less effective, often because it's no longer inflammation that is driving the pain. It's some form of dysfunction of the nervous system. Somewhere along that pathway from the foot to the spinal cord to the brain, there is some signaling error going on. And no matter what happens at the foot, if you take that thorn away and you've calmed it down and sat down and rested and relaxed, for some reason that message is still firing off in the spinal cord and going up to the brain, or the brain is not functioning as it should do by saying, listen, I don't want to hear any more, calm it down. So something goes wrong, and it's probably more of a nervous system or a processing problem. So we tend to veer away from the medicines that we use for acute pain and tend to veer a little bit more towards medicines that rationally might calm down the nervous system. Things like anti-epileptics, pregabalin, gabapentin, antidepressants, amitriptyline and duloxetine. But actually the evidence for these treatments in most types of chronic pain isn't fantastic.
Many people also say the side effects are really horrible.
Right, yeah. So let's take the best evidence for these treatments would be in a subset of chronic pain patients who've got neuropathic pain. So if we think about 44% of the population have got chronic pain, only about 10% of the population have got chronic neuropathic pain. And that's where these nerve pain-killing drugs, if you like, work best. But even in those populations, you'd need to treat between 4 and 7 people for one person to report notably improved pain. And that won't necessarily last for life, because the body develops tolerance to it. And as you say, somewhere in the region of 1 in 3 people will report significant side effects from these drugs with their use. Drowsiness, dizziness, sedation, disorientation, and the most common thing is weight gain.
Given that really the message coming through loud and clear here is that chronic pain is not amenable easily to reaching for a packet of pills like a headache, a short-term headache is. Given the prominent role that you pointed out for an emotional component, do things like homeopathy or reflexology or even acupuncture, is there an evidence base for those kind of interventions?
I will say there is an issue with evidence in pain, which is that it's very, very difficult to get good evidence for anything in pain medicine. This is partly because pain is so hard to define. When you look at things that reduce blood pressure, you've got a definitive endpoint. You've got a number on a machine that's fairly reliable that you can print and you can measure and you can compare from one day to the next. Pain is entirely subjective. So it is the report of the patient. And as we've said, it's so contingent on not just the lifetime that they've experienced, but that moment they're in. So day to day, the context that they're in and how they feel. So being able to filter all of that stuff out and look at one individual factor, like one tablet or one drug or one spinal injection or one needling technique or homeopathy, is notoriously difficult. And what you'll find is that a lot of the data is weak, doesn't really support an intervention across this very large population of pain patients. So acupuncture isn't going to work for the 44% of patients who've got chronic pain. But actually, there is probably a subset of patients with a specific type of pain for whom acupuncture is remarkably effective.
So is it reasonable then for a patient who comes to see you to have an expectation that you're going to have to try a few things, and it's going to be a bit of a suck it and see approach to work out what works best for them, and it's going to be a range of things, which are going to be behavioural changes, some psychological things, but also possibly some packets of pills, but there is no magic bullet. Is that a reasonable summary?
Yeah, I think so. I mean, I'm a firm believer we're at an age and a day where patients have resourced information. They come informed, and that's helpful. I like to share decision-making with the patient, discussing the various options. But part of that is accepting that just because something has worked for somebody else, it doesn't necessarily mean it's going to work for you. And it doesn't necessarily mean it's going to be appropriate to be offered to you. Let's try and break down what we think is the main driver of your pain, if we can do, treat that accordingly, but look at the big picture as well.
Anaesthetist Alan Fayaz, he's from University College London Hospital. It's the fact that physical pain is impacted by our mental health that makes all of this so tricky to untangle, isn't it? Separating cause and effect is the challenge. Are people who report high levels of depression and anxiety more likely to develop a pain condition? Or is their pain making them depressed and anxious? Luckily, it seems as if we're starting to see health as something that incorporates all these factors, which hopefully bodes well for those currently in pain. And that is where we'll have to leave it for this week. The Naked Scientists comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm James Titko. Thanks for listening. And until next time, goodbye.